Hima Girija Ponnapalli, working as a Java developer with AJA Consulting Services, Hyderabad. Today, I'm going to discuss two problems. Let me walk you through the first problem and then come up with the solution for the first problem and then go to the second problem. This is the problem. Find x sum of k long sub-arrays. And I'm reading the problem, and wherever it is needed, I am going to explain the thing in detail. And here is the problem. Firstly, you are given an array nums of n integers and two integers k and x. Here the array named nums was given. It consists of n integers and its size is length n, and the x sum of an array is calculated by the following procedure. Here we have to calculate the x sum. Means what does that mean was given here. Firstly, count the occurrences of all the elements in the array. Means say if in an array there are elements, repeating elements, we have to count the occurrences, like how many times each element has been there, we have to count it, and then keep only the occurrences of top x most frequent elements. Now in the whole array, what are all the repeating elements and their counts, we have to calculate and keep it. From that we have to take only the top x most frequent elements. Means say suppose x is 2. Here in the array, like 5 elements are repeating. In that only top most frequent element, top 2 most frequent elements we have to take. Means say suppose 2 and 3 are repeating, 2 occurred for 5 times and 3 occurred for 4 times, and remaining all occurred for only 2 times. We have to take 2 and 3 elements because they are the top most frequent elements. This is the meaning of the sentence. This sentence, if 2 elements have the same number of occurrences, say suppose the element 2 and 3 both are occurring for the 5 times each, the element with the bigger value is considered more frequently. Means here 3 is bigger element than the 2, so we have to consider 3 here in this. So after that we have to calculate the sum of the resulting array. Note that if an array has less than x distinct elements, say suppose we are asked to get the top 2 most frequent elements. If the array size is only 1, then the sum of the array will be the x sum of the array is the sum of the array itself. This is what it says. Then finally we have to return an integer array answer of length n minus k plus 1, where answer I means the each element of the resultant array should be the x sum of the subarrays from 1 ith index to I plus k minus 1th index. What does this mean? Here k represents the window size of the array. That's why the resulting array, whatever we get, will be from the resulting array size will be n minus k plus 1. This is the resulting array size, whatever the array we get at the end. And here is x is the most frequent elements. X represents the top most frequent elements. These many top most frequent elements we need to get from this window size and then calculate the sum of that particular topmost elements, and then we have to store it in the resulting array. Say if the window size is k, we get the resulting array n minus k plus 1th size, and in this window size we have to, for this window each time we have to get the top most frequent elements and we have to sum the elements in that window size. That is what the problem is, and we have to get the resultant array. And here now coming to the examples given. Here this is the array given. 1 occurs 2 times, 2 occurs further 3 times, and 3 for 2 times, and the 4. This is 1 2 3 4 5 6 7 8. 8 elements are there in this array. And here k was given as 6 and x is given as 2. K means window size and x is the topmost frequent elements. How many we have to take it? That is the represented by x. Here if the window size is 6, first 6 elements we need to take, like 0 1 2 3 4 5 till 5th index is one subarray. When we remove the 0th element, if we calculate it from first index till the 6th index will be one more subarray, and from second index to the last index, that will be one subarray. Here as discussed, like the resultant array will be only 3 elements because n is 8. Here n is 8, k is 6, so resultant array length will be 8 minus 6 plus 1 equal to 3. So the resultant array size will be 3. That is what output says. And here coming to each subarray, only elements 1 and 2 will be kept in the resulting array, because here topmost frequent elements we need to take. In this topmost frequent elements are 1 and 2, both occurred for 2 times, and 3 occurred for 1 time, 4 occurred for the 2 time. So only topmost frequent elements are 1 and 2, which we are taking the sum of the frequent elements. How many are there? All the sum of the elements we are taking and storing it in the resultant array. So this is 6. If we calculate the sum here, it will be 6. So the first index is the 6. And coming to the next subarray, here we are taking from first index to the 6th index. 1 2 2 3 4 2. Here the topmost elements are like 2 occurs for 3 times, so it is the 3 times, and remaining in the remaining elements other than the 2, one is 3, one is 4, and one is 1. The other one is 1. All these 3 has the same frequency, like all occurred for only one time. Therefore in this to choose, we have to choose the highest number. So here we are choosing the highest number, and we are summing up all the elements. Like 2 occurred for 3 times, these 2 occurred for 3 times, and we are considering 4 among the other elements. Therefore whatever the sum is, that is what we are storing in the resultant array. This is the 10. And next, coming to the next subarray, from the second index to the last index, in this 2 occurred for the 3 times and 3 occurs for the 2 times. Therefore we are summing up the 2 elements in how many times it occurs, that we are calculating the sum and storing the result in the resultant array. This is what I think this example does for understanding the problem accordingly. And the next example is simply like this 5 elements array, like array size is 5 and the window size is 2. The same, like the most how many frequent elements we have to take means it is 2. So in this, the length of the array is 6. So if we calculate the resultant array length, it should be 6 minus window size is 2 plus 1 equal to 5. So the length of the resultant array here, what it shows is also 5. Like, and what are the frequent most of highest frequent elements? That some are included and calculated and included populated in the array, resultant array. This is, and here since here, because since k equal to x means window size is equal to the topmost priority elements, I mean frequent elements, the answer of the resultant array will always be equal to the sum of the sub-arrays, calculated sub-arrays. That is what this statement is saying. And coming to the constraints, here the length of the array is in between from 1 to 50, and the elements in the array also will be in the range from 1 to 50, and the will be almost window size will be almost exactly matches with the, I mean, in between 1 and this array length, and the topmost frequent elements should be always less than in between the window size and the 1. Coming to the solution, the approach which I have done was presented here. Here the I'm returning the int array, the resultant array which was asked in the problem, and here I'm going to take the input as an int array and the window size k, and the topmost frequent elements is x, which was stated as in the problem. These are the input parameters which I am taking for this method, and n equal to this array length, and resultant array, as I have already discussed, it is from the length minus window size plus 1. Therefore here only the window size we are calculating, because we need to populate only this array. Like, therefore we are iterating till this length, till the resultant array length. In this I'm going to take a hash map for counting the frequency of the elements from the input array, and the window size. Here the next loop, the first loop represents only the for populating the resultant array. Here the second for loop represents for iterating through the window size elements. So here j equal to I plus k, it means like the second loop, here we are iterating the elements from 0 to k, I mean only window size. If it increments 1, if I increments to 1 plus k is just sliding. We are using a sliding window technique here, and also we are only iterating through the particular window size elements only. So accordingly, as we all know that we can populate into the map the frequency of the particular element. If at all this means map.getOrDefault states that if at all already the element is present in the map, either it will be getting that value plus add 1 to it and again populate it into the map, or else defaultly we are adding 1 to that. I mean, we are increasing the value if it is already there. If the element is already present in the map, we are increasing the value 1 by 1, else we are populating the map with the new key with the initial value as 1. That is what this statement says. And firstly, for window size, we are populating the elements according to their frequencies in this hash map. Then we are using a priority queue. As we all know, this queue represents executes or processes the elements in a first in first out order. But in priority queue, here the processing of elements happens on the basis of a priority, and we can prioritize according to our requirement. Like here I wanted to prioritize in context of in the context of frequency, whichever the element that has higher frequency, that should be popped out first. That is what I need. Therefore for that purpose I have used this comparator. Like in this each element, like priority queue, in this two elements are compared by using the comparator, and if both the frequency of A and B are same, then we have to get in an order of the highest, in an order that the biggest element I should get first. That's why I have returned the B minus A. Means map dot get A means if I have a key in map A, I have to get the frequency of that. If the frequency of A element and the frequency of the B element matches, then out of the, if B is bigger than A, then I have to get B minus A. I mean the element, say suppose I have 4 and 5, fourth element and fifth element. Fourth element frequency is also 4 and fifth element frequency is also 4. Then either of the two, and if both are, as both are equal, in either of the two I have to retrieve only fifth element because it is higher than 4. In that context, I have written this code. So to get the highest element, if the frequency of their values matches, I have stated that written B minus A so that it will sort in such an order. Then comes to, if this condition is not satisfied, I will simply get the highest frequent element. Say suppose element 5 has a 5, it occurs 5 times, and element 4 occurs for 4 times. In this it clearly states that fifth element is the highest frequent element. Therefore we will get only the fifth, I mean element 5. That is what this line explains. Here I am repeating this again. In priority queue, I am implementing the comparator according as per my requirement. Here, if the frequencies of the two elements, matches, I'll be returning the highest element of the, I mean maximum element of that is the highest element of out of the two. Otherwise, if this condition doesn't match, I will get the highest frequent element. That is what this priority queue. I have already configured the comparator into this priority queue as per my requirement. Then I am implementing this priority queue with the hash maps key set. Now I am adding each element of the key set from the map. In this map, I have added all the keys along with the values, along its values in the sense here frequency. But I only need the key set as of now, because if I add the element in the priority queue, I have added all the elements from the key set into the priority queue. Now as I need to get the overall sum of the top x frequent element, I have taken one variable initiating with x number. I mean this is the most frequent elements which we need for this window size. That's why while I am just counting down the values till from x to 0, and if the priority queue is not empty, we have to pop the element from the priority queue. And how many times this occurs in the hash map, that value I am getting here. I am retrieving this value from the hash map, and into that many times I am multiplying, because I need to get the sum of all the elements of that particular element. I mean frequency into the particular element. Say suppose here the topmost frequent element is 5. If I get 5, if 5 occurs for 5 times, 5 occurs for 5 times means 5 plus 5 plus 5 plus 5 plus 5 means 25. The answer is 25. That is what I am about to calculate here. Instead of adding one by one, I can simply multiply it 5 into 5, map dot get 5. In the hash map, I have the 5 element, and how many times it occurs also is present in the hash map as a value. So I am retrieving this top element from the hash map, this value gives how many times it occurs. Say it is occurring for 5 times. Therefore, the element 5, I am multiplying it with the 5, which gives me 25, and it adds to the resultant array element until the topmost frequency. This is if for one iteration, I mean for one cycle it does, and say if x equal to 2, for one cycle it is done, and for one more cycle until x becomes 0, the cycle continues, and therefore it will populate the whole sum into the resultant array element. For this is one of the element in the resultant array, so this whole process will continue until the resultant array size is completed, like till the res dot length, I mean this array size, till that many times the whole for loop will be continuing and then populate each element of the resultant array. Once after it is done, we can return the resultant array. Here I can simply take the first example and I can explain it the same. This is the array. Say suppose for the window size 1 2 3 4 5 6 times, and all these will be populated in the hash map. So for example, 1 for 2 times, 2 for 2 times, 3 for 1, 4 for 1. For 1, and here we are adding all the elements like 1 comma 2 comma 3 comma 4 to the priority queue. And here say suppose x equal to 2, here 1 and 2 are getting populated. These are the most frequent elements. So here 1 occurs for 2 times. Therefore, 1 into 2 plus, in the first loop, it will continue to run for 1 time, wherein, and after that again 2 occurs for 2 times. This is the resultant sum, which is equal to 6. This is one iteration. And again till the resultant array will be populated, this whole loop runs again and again until this condition is satisfied, and finally we are returning the resultant array. The whole process, let's execute the problem, wherein I have already taken the examples which I have shown it here. Example 1 and example 2 have already taken as an input for these methods, and I'm executing the same. Let's execute and see. This is the result for the first array. This is the result of the first array output, and the output for the second array which I have taken is this one, which we got as a output. And coming to the time complexity, here we are sliding the window, I mean we are iterating the elements and we are populating it in the hash map, and then we are populating it in the priority queue also. So finally the loop is like we are populating according to the window size and then using the priority queue. And here, therefore, and one loop is running into the another one, therefore the sliding window, it is O of n into k elements we are populating into the hash map and also into the priority queue, therefore n into k log k. This is the time complexity of the problem. And also when coming to the space complexity, the resultant array in the worst case it can be till O of n, and for the temporary structures hash map or priority queue we are populating it only for k times k elements, therefore it is like O of n plus k. This is the space complexity. This concludes the first problem, and then we will be going to the next problem. Here, coming to the second problem, the problem is named as alternating groups. The problem is about finding the total number of alternating groups in an array. Here, I'm going through the problem first and then going to the solution approach which I have coded. There is a circle of red and blue tiles. You are given an array of integers colors. The color of the tile I is represented by colors I. Means we are given an array and each element of the array represents by the color. If the element of the array is 0, then it represents red, and if the element of the array is 1, then it represents blue. Every three contiguous tiles in the circle with alternating colors is called an alternating group. So if the first element is 0, the next element should be 1 and the next element will be 0. Then it is considered as an alternating group. The same way, if the first element is 0, the next should be 0, the next should be 1, and then the next element should be 0. 0, 1, 0 or 1, 0, 1. Either of them can be considered as the alternating groups. So finally, we have to count the number of alternating groups in the complete array, and we have to return that count as an answer to the problem. Now, since that colors represent a circle and we are considering the array as a circle, therefore the first and last tiles, the first index element and the last index element are next to each other if we consider that array as a circle. Therefore, in this example, here there are two examples for representing how it works. The example one is of a tree-sized array, and in this there is no alternating group because 1, 1, 1, all three are the same elements, therefore it is 0. And in the second example, it is a 5 element sized array, and here, like as we said, 0, 1, 0 is one alternating group. As I already discussed, like last element is next to the first element. If we consider this array as a linear one as a circle, here we have two edge cases, like last but one element, last element, and the next element is the 0th index. So 0, 1, 0 again, 0, 1, 0. Therefore, this also represents one alternating group, and the other edge case is like last element and the next element will be 0th element and the next element will be the first index element. This also is one more alternating group. There are two edge cases in this problem. One is the last but one index element, the last index element, and the first index element. And the same way, last index element, zeroth index element and the first index element. These two are the edge cases which we also have to consider for counting the alternating groups in any of the array which was given. And the constraints given here are the array length is in between 3 to 100 and the elements of the array is only 0 or 1. It should be equal. And here I have just represented the same array. If at all it is, if we consider it as a circle, how it behaves. I mean, how do we represent? Like 0 to 7, if we represent the array, the same, we are representing the array linearly. Here, if we consider it as a circle, here the 0th element will be next to the last element. And the same way, 0th, first element will be the next to the 0th element. Like the edge cases, the last two edge cases here, and the array as a usual representation. The first line is array in usual representation, and if it is in the circle, there are two edge cases which I have kept it here for better understanding. Coming to the problem, here I have taken only the array as the input. N is the length of the array, and for the alternating groups count, I have initialized a variable with the name count, and here I am iterating the elements through first index and the last but one index, because we have to compare each element with either the previous element or the next element. Therefore, to avoid the index out of bound exception, I'm just taking it from the first index to the last but one index, so that we can compare easily with the 0th element and also the last element without getting any exception. And the edge cases, we can handle it at the end. Therefore, only from first index to last but one index, we are iterating and comparing it with it. So say suppose if the element is 0, the previous element should be 1. Here that's what I have written. Like if the current element is 0, the previous element means I minus 1th index element should be 1, and the I plus 1th element means the next element should also represent 1, should also be 1. Means either if 1 is blue, 1 represents blue, 0 means red, and 1 again blue. Blue, red, blue. In that way, in this case, we can increment the count by 1. And also say suppose if the element is 1, the previous element should be 0 and the next element also should be 0. Then only we will increment the count again. Either of the two cases, we are going to increment the count. Therefore, all these two cases I have covered it in the iteration, and I am iterating all the elements. And finally, I am going to handle the edge cases as I have previously covered. Like this is the 0th element, this is the first index element, and this is the last index element. Last index and 0th index and first index. This has two variations. Say either it should be 0, 1, 0. Like last one, if it is 1, the middle one should be 0 and the next one should be 1. Either this is the one, and in this there is one more variation. Either it should be 0, 1, 0 or 1, 0, 1. Either of the two cases, we have to increment the count again. And the same thing, the next edge case is like last but one element, last element, and the 0th element, 0th index element. So in this case also it should be 0, 1, 0. And there is a variation in the same case, like it should be either 1, 0, 1. Therefore, in either of the cases, we need to increment the count and we have to return the count. And coming to the space complexity, here we are not using any of the data structures to store the values or for calculating these alternating groups, we are not using any extra data structures. Therefore the space complexity is O of 1 and the time complexity is O of n, because we are iterating completely from the first element to the last element. Therefore how many elements are there, that many elements we have to iterate for getting the alternative groups. Therefore the time complexity is O of n. This is all about this problem, and let's execute this problem now. Okay, let me comment out this and then we will execute. Zero 3 are the expected results for the this one. Like in this there is no alternating groups, there is the expected value is 0, and the same array example as above which I have discussed. In this we have 3 alternating groups, therefore the result is 3. This concludes the problems and explanation. Let's catch once more again.